I'm Anil Kumar. Welcome to my series on algebra. We're discussing surds in this particular video. We'll talk about some examples from previous test papers. Take it as a test practice. We'll have 10 questions in this particular video to answer. I would like you to go through these questions, pause the video, answer them, and then look into my suggestions. So on the screen, you can see the first 7 questions. The first one is to prove that 1.6767, that is a recurring decimal, which you could also write this as 1.67 recurring, is not an irrational number. That means you can write it as P over Q as a rational number. Question number 2 is, which of the following expressions are not equivalent? So here we have given 4 expressions. You can say expression A, B, C, and D. So which one of these are not equivalent? 3 is x plus 1 over x to the power of half plus x to the power minus half can be written as a plus square root b. Find the value of a and b. 4. Simplify cube root of 54 plus cube root of 128 minus cube root of 250. You can either evaluate it, right? So you can evaluate. Okay. Question number 5 is a rectangle has length of 1 plus square root 3 centimeters and area of square root 12 centimeters square. Find the expression for its width in the form of a plus square root b. Question number 6. Find the value of k if 243 square root 3 equals to 3 to the power of k. Question number 7. Given that square root of 3 plus 2 square root of 2 is equal to square root a plus square root b, find a and b. That's a very important question from test point of view. Now let's move them on the top. Question number 8 here is evaluate square root of 2, 20 minus square root of 20 within square root. We have a nested infinite series, right? So this is our nested infinite series. How do we evaluate such a series? Question number 9 is, find the perimeter of the triangle ABC where coordinates of A, B, and C are minus square root 2, 0, minus square root 5, 0, and square root 3, 0, respectively. Question number 10 is another very important question. 1 over square root 1 plus square root 2 plus 1 over square root 2 plus square root 3, and so on till 1 over square root 8 plus square root 9 is equal to k. Find the exact value of k. These are very interesting questions from any examination point of view. I'd like you to actually answer them, understand their solutions. That will really help. Let's begin with the solution of the very first question, which is about writing 1.6767 as a rational number. So now here, let's also understand few concepts. When we're talking about surds, what are surds? A surd is an irrational number of the form of square root of n, where n is not a perfect square, right? Now, what is a rational number? Rational number can be written in the form p over q, where q is not equal to 0, right? So denominator you cannot divide by 0. And where the greatest common factor between p and q is 1. So when you write it in this particular form p over q, we say you have written it in the lowest terms. There is no common factor between them except 1. Now, irrational numbers are real numbers that are not rational numbers. So when we say that a particular number is not an irrational number, we really mean that it is a rational number. If it is a rational number, we have to write this in the form of p over q, right? So the question could also be said as write 1.67 recurring in the form of P over Q, where Q is not equal to 0. Correct? So that could be another way of writing the same question. So it becomes a rational number. So let us see how do we write it in this particular form. So let us say that A is a real number which is equal to 1.6767 recurring. So since there are two digits after the decimal which repeat, we will multiply this by 100. So when you do that, multiplication by 100, you get 167.67 recurring, right? Now, we can take away the first equation from the second equation, correct? So if I do equation 2 minus equation 1, in that case, 100a minus a will be 99a. And on the right hand side, all the digits after the decimal will cancel away. So we get 167 minus 1, right? So we get 166. And so we get the answer of A as 166 over 99. Since you can write this in this particular form as a rational number, it is not an irrational number, it is a rational number. That is how you can answer this question. Clear? Question number 2. Which of the following expressions are not equivalent? So basically, you have to simplify each one of these expressions and then see what do you really get. So the very first one, which is 6 square root 2 minus 4 square root 2, like terms, just take away. So we get 2 square root 2. The second one is, I've just changed the order while writing. So 8 over square root 18, or rather this one is given here. So 6 square root 8 plus square root 8 plus minus 5 square root 8, which is the second one here, is, you have the like terms, right? So you can do 6 plus 1 minus 5, you get 7. Which is 2 square root 8. Now, square root of 8 can be written as 4 times 2. 4 is a perfect square. Taken out, when multiplied by 2, we get 4 square root 2. So what you get here is 4 square root 2. So clearly, first and second, they are not the same. Let us see which ones really match with one of these. The next one here is 8 over square root 18 plus 4 over square root 18 equals to 12 over square root 18. Since they have the common denominator, we added the numerators. Now, square root 18 means 9 times 2. So 9 can be written as, square root 9 can be written as 3 square root 2, simplified as 4 over square root 2. You can rationalize, and once you rationalize, you get 2 square root 2. So we get these two as same, right? So we get 2 square root 2 here and 2 square root 2 there. So those two are equivalent expressions. The last one here is 60 over square root 450. 450, you can split it into 9 times 5 times 10, for example. Now, 10 could be written as 2 times 5. Now, that helps us to figure out how do we really simplify this square root. So we can write this as 60 over 3 times 5. 3 is square root of 9. 5 times 5 is 25. Square root is 5. Square root 2. So we again get 4 over square root 2, which can be written as 2 square root 2. So we find that these three are exactly same, evaluated to 2 square root 2, and the only one which doesn't match is 6 square root 8 plus 8 square root 8 minus 5 square root 8. Perfect. So that is how you solve it. Example 3. X plus 1 over x to the power of half plus x to the power minus half is a plus square root b. So let's find how to solve this. Now the best way to solve this particular question is to multiply the numerator and denominator by square root of x, right? Which is x to the power of 5. So one and the same thing, remember that is square root of x, correct? So when you multiply by square root of x in the denominator, square root of x times square root of x is just the number variable x, and that becomes 1. So we get x plus 1 in the denominator, and now you can cancel x plus 1 from numerator and denominator, and you get your answer, which is square root of x. Is that clear to you? Now once you get square root of x, then you have to see how does it match with a plus square root b. So square root of x should be equal to a plus square root b. Clearly, a has to be 0, right? and the radical part b should be equal to x, and that becomes our answer. Clear? Let us also take an example based on cube root. Here is question number 4. This time we will work with cube roots. So we are given cube root of 54 plus cube root of 128 minus cube root of 250. We need to simplify. That really means that we need to evaluate, right? So we can say sometimes the question could be evaluate exact value. Whenever you're working with cube root, you should keep in mind that, what is 2 cube equals to? Well, 2 cube is equal to 2 times 2 times 2, which is 8. What is 3 cube equals to? 3 cube is 3 times 3, which is 9 times 3, which is 27. 4 cube is equal to 4 times 4 is 16. 16 times 4 is 64. And 5 cube is 5 times 5 is 25 times 5 is 125. So likewise, if you have some cube roots in your mind, then it is easier to solve such questions. So we'll keep this in mind, and now we'll try to solve it. So the strategy here is, when we're talking about 54, how can you split 54 into two numbers so that one of them is a cube root? That is the whole idea. So think like this. We have 54 here. Now 54 is a product of 3. We could write this as 27 times 2. That is 54, correct? Knowing fully well that 27 is basically equal to 3 cube. And therefore, we can actually write this as 3. This is the cube root, okay? So cube root of 54 we are talking about. So 3 times cube root of 2. Since cube root of 27 is 3, correct? So that really means that cube root of 27 is 3. And therefore, we could write this as 3 cube root of 2. Is that clear to you? So this is the strategy which we are going to follow. So as you can see here, 54 cube root has been written as 27 times 2 cube root. Now 27 cube root is 3. Remaining is 2 cube root. So that is how we could simplify it. Perfect. So I hope this step is absolutely clear. Now similarly, what is 128? 128 is 64 times 2, and 64 is cube root of 64 is 4, and therefore we wrote 4 outside and cube root 2. Similarly, 250 has been split into 125 times 2, where cube root of 125 is 5 times cube root of 2. Now they are all similar terms, and we can write them as 3 plus 4, which is 7, minus 5, which is 2. So we get 2 cube root of 2 as our answer. So I hope the steps are absolutely clear. Now we'll take some interesting questions. Begin with a word problem here. A rectangle has length of 1.1 plus square root 3 centimeters and area of square root of 12 centimeters square. Find the expression of its width in the form a minus square root b. So let's consider area of a rectangle, which is length times width, right? So whenever we say area of a rectangle, it is length times width. So we're given that the length of this rectangle is 1 plus square root of 3. And we want to find the width in the terms of a minus square root of b. And we know that the area is square root of 12. Correct? That is the scenario. So when you multiply length and width, so when you do length and width, you get area. So that is what we've done here, multiplying 1 plus square root 3 with a minus square root b, equating it to the given area of square root of 12. We need to find the value of a minus square root of b, so let us isolate it. Once you isolate, we get a plus square 1 plus square root 3 in the denominator, and then we rationalized it by multiplying both by numerator and denominator over the conjugate of 1 plus square root 3. So we get a term which can be simplified to 2 square root 3 minus 2 times 3 in the numerator, and 1 square minus square root 3 square, which is 3, in the denominator, right? So, simplifying, we get 2 square root 3 minus 6 over minus 2. Dividing, it could be written as minus square root 3 plus 3. Rearranging, we get 3 minus square root 3. Now, when you compare with a minus square root b, like terms should be same. A is equal to 3 and b is equal to square root of 3. So that is how you can find your solution. So this is a very interesting way of finding square root of a surd, right? So that is a very important method. Let's move on and take the next example. We need to simplify an expression. In this case, find the value of k is 243 square root of 3 is equals to 3 to the power of k. So let's write them in exponent form. So here we have written them in exponent form. We get 3 square root is 3 to the power of half. And what is 243? 243 is actually equal to 3 to the power of 5, right? So 243 is 3 to the power of 5. Now we have used this sum, which is what is 5 plus half. 5 plus half is 5 and a half as written here. You could also write this as taking common denominators, 11 over 2, right? So on the left hand side, we get 5 to the power, 3 to the power of 5 and a half, and on the right side, we have 3 to the power of k. So clearly k is equals to 5 and a half, which is 11 by 2. So that is how you can solve the value of k. And therefore, our answer will be that k is equal to 11 by 2. Correct? Question number 7. Given that square root of 3 plus 2 square root 2 is a plus square root of b, square root a plus square root b, find a and b. Now, strategy here is very similar to the strategy which we had adopted earlier. I'd like you to pause the video at this stage, answer this question yourself, and then look into my suggestions. Now, we are already given the square root of a number is equal to square root a plus square root b. We need to find what a and b are. So the first step should be you can square both sides, right? So if you square on both sides, you get rid of this square root sign. And on the left side, we get 3 plus 2 square root 2. On the right side, we expand it using the rule a plus b square root, right? So, and what we get here is a, which is square of square root of a, plus 2 times square root ab plus b. So you can rearrange and then compare the like terms just as we did last time, right? So when you compare the like terms, we get a plus b equals to 3 and ab equals to 2. Now these two equations we need to solve, correct? These two equations we need to solve. There are many different ways of solving this. The best method is as shown here. You can actually multiply product, you can use sum and product, correct? So you can use sum and product. So we are looking for two numbers whose product is 2 and whose sum is 3. Do you see that? The numbers are 2 and 1. They will satisfy this particular equation. So we can say 2 as a and 1 as b, and that will help us to equate or solve this particular question. You can check your result also. Perfect. So that is how we are going to solve this. Now from here, we also learn a very important trick, and that is whenever you are given this particular form, which is square root of p plus minus 2 square root q, as we have here, in that case, it could always be written as sum or difference of square roots as shown here, and the value of a plus b will be equal to p and ab will be equal to q. You see sum and product form. So a plus b is p and their product is the thing within the radical sign q. Correct? So that helps. You can try with this trick and solve the next question which is given here. Square root of 3 minus 6 square root 2 equals to square root a minus square root b. Find the value of a and b. Okay. Now here is another very interesting question seen so many times in competitive examinations. We need to evaluate this particular expression, which is Square root of 20 minus square root of 20 minus square root of 20 and so on is an infinite series. So the process here will be similar to our very first question, okay? So we are saying that let this expression be equal to x. Now, if you square both sides, you get 20 minus the same term, which is 20 minus x. So x squared, bringing them together, plus x minus 20 should be equal to 0. This can be factored, right? Now, 20 can be written as x minus as a product of 4 and 5, right? Since we need positive x, we'll keep a bigger number as positive. So x minus 4 times x minus 5 equals to 0 gives you the solution x equals to 4, only because the radical sign is always positive, correct? So you see that the product of two numbers which gave us 20, the consecutive numbers, were 4 and 5. The smaller one is the solution when we're talking about negatives, right? So that gives us a strategy. If it is positive, then it is the bigger one which is the answer. You get the idea, right? So you can apply this particular strategy, use this method, understand how can we solve similar questions. So the trick here is 42 can be written as 6 times 7, and since we have positive, the solution will be the bigger number 7, right? So if this is positive here, in that case we're looking for a bigger number as answer. Is that clear to you? So the answer in this case will be 7, but I like you to follow the method and see whether you really get it. Okay, here is another very interesting question taken from previous test paper. The question here is, find the perimeter of the triangle ABC where A is minus square root 2, 0. These A and B are x-intercepts, you can say, and this is minus square root 2, and B is square root of 5. C is the y-intercept, which is square root of 3. So you are given the three intercepts, you need to find the shaded area of this particular triangle. That's the question, correct? So, in this case, we are finding the perimeter, not the area. Okay, so we have to find the perimeter of this particular triangle. So basically, you need to find the three lengths. Now, whenever you're given the x and y intercepts, you know the two sides of the triangles. You can find the third side using Pythagorean theorem, correct? So the concept here is use Pythagorean theorem. Correct. So in this particular case, you have to find AC, for example. This side is square root of 2, the other side is square root of 3, and therefore AC will be what? AC will be 2 plus, square root of 2 square will be 2, square root of 3 square will be 3, and then square root. So that gives you the value of AC. And that is what we found here. As now I'll just highlight AC for you, which is A to O being the origin, correct? O being the origin, so we get 8o square plus co square, which is this, right? So we get this hypotenuse as square root of 5. So likewise, you can find the other hypotenuse also, which is CB or BC. So in this case, square root of 5 plus square root of 3 will give you square root of 8. The x-intercepts give you the two sides of the base, add them up to get this length A to B, right? So A to B is the sum of the sides A square root 2 and square root of 5. Okay. So we get the three sides which we need to add to find the perimeter, and therefore perimeter is sum of all the three sides, and then simplify the expression to get this as 3 square root 2 plus 2 square root 5 units. So that is how you could answer it. So that should be very clear. Now here is the last question, which is again a very interesting series, which is higher level algebra. We have 1 over 1 square root 1 plus square root 2 plus 1 over square root 2 plus square root 3, and that kind of series. Actually, in general, we could actually extend this series to 1 over square root of n plus square root of n plus 1, correct? You could actually extend this series. Now, to solve this series, let's try to understand a general term, and then we'll easily do it. So consider the general term, which is 1 over square root a plus square root of a plus 1. So that's the term. You can rationalize this. Once you rationalize, the denominator will be difference of squares. You get a minus a plus 1. In the numerator will square root of a minus square root of a plus 1. So the denominator here is minus 1. That is to say, we can write now the expression as square root of a plus 1 minus square root of a. So once we know that each term could be written as difference of their terms in the denominator, we can actually rewrite the series as, see, the first term will be square root of 2 minus square root of 1, correct? That is what our general form is. Similarly, the next term we can write square root of 3 minus square root of 2, and similarly we can write all our terms. Now the last term here will be kind of like this. Now from this series you can see that those negative terms will try to cancel the other positive same term. So square root of 2 gets cancelled with square root of 2. However, square root of 1 remains. Do you see that? So the number, when as we move on one by one they get cancelled. So square root of 3 will be cancelled by minus square root of 3 next term. However, the two terms which remains will be square root of 9 and minus square root of 1. So when you do that, you get square root of 9 minus square root of 1, which is 3 minus 1, and that is equal to 2. And therefore we get our answer, which is k equals to 2. You get the idea, right? So in general, this series answer will be, if you have that kind of a series up to n, it will be square root of n plus 1, right? So which is the last term minus square root of 1, right? So that is going to be the general solution for such a series. Once you know the solution, you can easily write it in any multiple choice test paper. So I hope that really helps. So now we have understood how to solve all these questions. That should give you a good review on what you've learned so far and really help in your own test. I hope that helps. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. And if you want to learn from me, you can always send me an email on the address given here. Thanks for your support and all the best.